So I'm going to give another proof of the Pythagorean theorem. It's actually the same proof of the Pythagorean theorem, but I'm going to sort of build from the ground up. In other words, there's a diagram that I had before. I'm going to sort of build that up as we go. I think it'll make things a little more clear about what's what. The downside is that the diagram is not going to look nearly as nice as it did in the previous video. So if this is the only video about the Pythagorean theorem that you're watching, I'm going to give a proof that was given by where did the name go? Sorry. Sorry, that's not right. Whoops! Wow. Almost right. Okay. They probably, as I said in the first video, they probably did not call it the Pythagorean theorem, but that's what I'm going to call it because that's what I call it. And again, here is the diagram that I'm going to draw. So I'm going to start with a right triangle. So I will call this side length B, and I'm going to call this side length here A. Now, when we have a right triangle, one of the side lengths is longer than the other one, and so for this one, I'm going to say that B is the longer side length. And now I want to draw the hypotenuse. So I'm going to do this. And again, my drawing is not going to be great, but that's the hypotenuse. I'm going to call that H. And of course, the claim is that A squared plus B squared is equal to H squared. Now, the geometric, reasoning here is that H squared is the area of a square that has this as one of its side lengths. So that's what we're going to do. I'm going to start by drawing a square with that being one of its side lengths. Now, the image here is not going to be great, so I just want everybody to be prepared for that. But I do want to get something kind of close to being correct. So I'm going to use my compass here to try to get an idea of at least what the side length is going to be. So eyeballing a 90-degree angle, maybe right here. So we'll have something coming up like this. Let me try to do a little bit better. Now, of course, we can construct a right triangle, a square using a straight edge and compass, but I don't really want to go through all of that as it involves quite a lot. Anyways, so that's one of the side legs, or one of the legs, or one of the sides of the square. Next, we're going to have something like this, maybe. Close enough. Okay, and then finally do my best to connect these here. Okay, now again, obviously, this is not a perfect square, and like I've mentioned before, in some ways that's desirable. But okay, here's what we have. So the next thing that I'm going to do is I'm going to draw the other half of this rectangle. So in other words, this triangle right here is half of a rectangle. In particular, it is half of this rectangle. So I'm going to go over like this, and then I'm going to draw the blue rectangle like that. Okay, now what I want to do is I want to draw this right triangle, but up here. So it's going to be like this. Okay, and so this is B, and this is A. And again, what I want to do is something similar. I want to draw a triangle, the other half of this triangle, meaning this, like that. Okay, so we're gonna have this. And now I want to do something similar. I want to put triangles there and there as well. So we're gonna get something that looks like this. Again, I want a right triangle. So like this over here. Okay, and now what I want to do over here. What is happening? Okay, so now what I want to do over here. Sorry, the picture is getting not good enough that it's okay. So I'm going to draw a similar rectangle over here. So it's going to be something that comes down like this. Okay, so it's all right. And then this length here is going to be partly blue and partly purple, like that. Okay, and then that length there is going to be partly blue and partly purple as well. Okay, and then finally I'm going to draw a rectangle over here, or not a rectangle, but a triangle. The other, have something like this, and then come down with a purple line like this, and then now again draw the other half of the triangle, so something like that. Okay. So this is a much more exaggerated picture than the one that's in the book. Okay, but it actually doesn't look nearly as bad as I thought it was going to be. Anyways, so let's look at the area in the black square here. I want to try to compute the area of that black square in terms of A and B. So h squared is one way to write that. But let's look at the area of this triangle right here. Well, the area of this triangle is the same as the area of that triangle. That was like what we did by construction. The area of that triangle is the area of that triangle. So this is equal to 1/2 AB. Okay, so we have, let me mark this out because we've considered its area. Now what about this right here? Well, the area of this triangle is the area of that triangle, which is 1/2 AB. And so we see this one, and this one. The areas are all going to be 1/2 AB. So it's going to be 1/2 AB plus 1/2 AB plus 1/2 AB plus 1/2 AB. That's the triangles that I just marked out there. Okay, and then the last area that needs to be computed is this big area right here. So let's think about what the length, what each one of these side lengths are. Well, notice that this distance right here is equal to this distance minus that distance. Now this long distance is just B and the short distance is just A. So this distance right here is B minus A. Okay, and up here, this distance is equal to this distance minus that distance. So again, this right here is equal to that distance minus that distance. But again, that's just B minus A. And similar things here. This is equal to B minus A, and this is equal to B minus A. So the area of this sort of central square is B minus A squared. Now, B minus A squared, I'm going to write this as A minus B squared, because they're equal to each other. And then we have 4 1/2 ABs. So that's going to be plus 2 AB. Now, if we do the algebra here, we get A squared plus B squared minus 2AB, then plus 2AB. So this is equal to A squared plus B squared. And so we have H squared is equal to A squared plus B squared, which is what we wanted to prove. Now again, this is not substantially different. It's not substantially different than the first video on the Pythagorean theorem that I posted. But now you saw me draw the rectangle as I went, which I don't know if the other one wasn't clear about what was going on. Maybe this one is a little more clear. But just anyways, I think proofs of the Pythagorean theorem are great, and I've enjoyed this one for as long as I've known about it. So I hope you enjoyed it as well. And as always, if there's questions about things I've done here or anything like that, feel free to ask them in the discussion post, or interact with this in the discussion post. If you think I made a mistake somewhere, anything like that. Or if there's a, if you have another proof of the Pythagorean theorem or something like that, or another thing to add here, I'd like to hear that as well. Because like I said, I like hearing about proofs of the Pythagorean theorem.